Thank you. So I am here talking about the Conrad Garage Suite, which kind of fits in the middle of the other two projects. So we've got our DP, we've got our BP, but we only got the BP about 2 or 3 weeks ago. So we haven't started construction, but we have some data. So, and also similar like the other projects, it's not just one technology, it's not one product, it's trying to do everything the best we can. So what is a Conrad Garage Suite? It's a 2-bed, 1-bath, backyard suite with a garage/workshop below on an existing lot in Calgary with a single-family home on it. And the goals from the start were high-performance prefabricated envelope, low-carbon materials, all electric and net zero on-site energy, and using readily available products and technology. And similar to Steve's, demonstrating cost-effective and replicable missing middle typology, smaller than Steve's, the backyard suite. So here's our plan. So the main floor is kind of an oversized garage that can also work as a workshop, storage area that can also be a bit of an office, a bathroom, and internal stairs going up to the 2-bed, 1-bath with open living room, dining room, and a deck onto the alley. So the building envelope, similar to Terrian's, is the Savix prefabricated dense pack straw, the walls that are R40 and the roof that is R60. And similar to Steve's, we have the SI Constructions Polycore prefabricated R37 foundation walls and R30 floor, so very little concrete. And this is about the first time that both of these products work together. So we worked with both the engineers to kind of optimize the structure and the connection details between these two prefabricated systems. It's virtually thermal bridge free. It's all made in Alberta. This is what circular and scalable we think should look like. For this project, we ended up bringing windows from Europe, from ZZ Construction, who's a local construction company and imports the windows. But there are 7 UPVC windows and doors from Europe, and we're going to insulate the frames on site. So we don't have any pictures we haven't built, but these are kind of stock photos for what Savix prefabricated dense pack straw panels look like. And these are what SI Construction's Polycore foundation walls and our slab looks like. So our slab and the Polycore walls are steel studs and foam. The steel is all on the inside, but on the outside you still get the little plastic tangs. So just like ICFs, you can put your siding directly to the foam on the outside. So as far as energy production and roofing, so we're going to use a standing seam concealed fastener metal roof. We're going to use the Che Power building integrated solar PV panel racking system. And we've optimized that system with the Savix system. So there is no metal roof below it, and we are using minimal sheathing below it as well, just to kind of reduce the embodied carbon and the costs. Hot 2000 has modeled the building, and we're pretty close to net zero on-site energy. We were not quite there with the modeling with 21 500-watt panels, so we've now looking at adding another 5 425-watt panels on the south canopy, all controlled by microinverters to hopefully get us to actual net zero on-site. So these are, again, stock photos of what the Che panels look like. They're basically a plastic frame that kind of overlap into each other that give you the venting and the drainage, and then solar panels mount directly on top of that. So the big difference is there is no roof below it. So embodied carbon and cost savings. As far as mechanical systems, so mechanical system in any high performance building, and this is built in the near passive house standard, is supposed to be simple, simple to install, low cost, and simple to operate. So we're just using an 80% efficient ERV, but with MERV 13 filters. We're currently using just an electric resistance hot water tank. There's only going to be 1 or 2 occupants in the suite, so we're expecting low water use. So we think electric resistance is a better overall option versus a heat pump hot water tank, and the cost savings between the 2 tanks will go towards more panels on the roof. Heating and cooling is likely going to be use one of the newer through wall air source heat pumps. So no refrigerant running throughout the building, but we're still deciding on that one. All equipment, we're almost there, but have not officially picked our equipment, but simple and hopefully low cost. As far as electrical, there was a 100 amp, 200 volt circuit to the existing home. So we've upgraded that to a 200 amp, 200 volt circuit because the existing home is also on a deep energy retrofit pathway. So by the time you add an electrified existing home, the electrified suite, and some electricity for the possible workshop, we needed 200 amps. To help lower our peak load, we are going to use a 2-burner 1500-watt induction cooktop instead of a larger one. And we're going to use a combination microwave and convection oven to, again, reduce the peak loads. We all will be putting EV charging in, and it'll be controlled via circuit pauser or load share device. And we're going to use an all-in-one 15-amp 120-volt washer and condensing dryer, and then the big bus bar on the electrical panel for that solar PV connection. We have done some modeling for Elements Integrated Design, and so we meet tier 4 of 5 on the building energy code. We modeled it against both a gas and an all-electric reference house. And in both of them, we're about 43 or 44% better than the reference house before the solar production, and 88 and 84% with the solar production. So 44% might not sound like that big of an impressive energy reductions, but it's interesting when you get into really small suites like these are, that there's not much left. So 52% is the fixed appliances and internal loads that we can't change anything. And then the other 38%, that is domestic hot water at electric resistance 100%. And again, that is a fixed based on the estimated occupancy. So we've managed to get the things that we can really control, the space heating and the fan, down to only 10% of the total energy. So we're pretty happy. It's just interesting that it is only a 44% reduction. There's the heat loss by components. That's pretty standard. As in any building, it's just a lot less because the overall energy use is less. We also wanted to model the embodied carbon. So we use the Material Carbon Emissions Estimator, the MCE squared tool, which is just a plug-in to HOT 2000. It's pretty new, so it's taken a few little iterations and goes at it. But right now we're at 1.2 tons of carbon, which is a 93 or a 94% reduction over kind of code minimum. So we're not quite at zero, but we're pretty close. And how close is that, or how do we get that low? Here's the breakdown. It's all about the negatives. So you need some negative numbers to reduce that carbon, because some things are going to be positive. So the big negatives were bamboo flooring and linoleum flooring. And then the big other two ones in the roof and the walls are that dense packed straw. And then of course we have some foam in the foundations and walls and some positives. So as far as the most emitting items, we do have a lot of EPS foam. EPS foam is fairly low, but we need a fair amount of it to insulate the walls and the slab. So that takes up a fair amount. Then windows, then concrete. So we only have about a 10 by 14 inch strip footing. So only about 3 or 4 cubic meters of concrete. So much less than what would be if we had a full concrete slab. But it still starts to add up, but all the numbers are smaller. So 1.2 is pretty good, but what about the things that we don't count? Unfortunately, the tool is only a cradle to gate tool, and it doesn't count right now any of the mechanical, electrical, plumbing, or many finishes. So 4Elements did kind of a bit of research, and some of the stuff that aren't counting actually is right now adding up to larger than what we are counting. So still some work to be done, but we're starting from a really good point. And what we think the best use of this tool is, this is an example of all the options for siding, because every building needs some type of siding. So when you can look at the different options and the embodied carbon effects, and then compare these to your fire resiliency, your durability, and cost, and all these other sometimes contradictory optimization paths, this is how kind of we think is best using this tool to kind of reduce that carbon on a unit by unit or part by part basis. Next, we also wanted to model our operational carbon. So again, that's how much carbon is used through the life of the building. We modeled it both with comparing to a gas, but we will be all electric. So we are again about 43 or 44% reduction before on-site renewables, and 78 and 88% if we include those on-site renewables. The interesting and annoying number is that if we went all gas, we'd actually have less carbon emissions, because right now the Alberta electrical grid is more polluting from a carbon perspective than the natural gas or fossil fuel grid. So that's why we really need those on-site renewables to reduce that. Because if you look at the annual carbon with on-site renewables, then we are lower being all electric. And then finally, talking about costs and performa. So we're not too far along, but right now the full construction budget is around $450,000 for what is essentially a 1,500 square foot, two-story home, as the whole garage level has the same insulation level as the upper levels, and the garage level is actually designed to be potentially converted into a suite in the future. So $4,500 for a 1,500 square foot house works out to $300 per square foot. Obviously, there's no basement, but that $300 per square foot we think is in that same range as what a code minimum house would be built at these days. Number is $21,000 to increase our water line because we needed to go up to 1 inch, and also $35,000 to get us to net zero on-site energy. So does this make sense? We will figure that out as we go along. The first occupant is going to be the owner's mother-in-law, who right now is paying about $2,500 for an assisted living unit somewhere else in the city. So for using that as rent, we are going to try to create a pro forma with also our first year of utility data to see let's see if this actually does make sense. But from what we've seen on this project and a few other projects where we're using the Savic and the Polycore products, they've been shown to be cost effective in multiple projects right now. And of course, being prefabricated, they save weeks to months off of the construction schedule. So that's the Conrad Suite quickly.